Today we are going to see about Pslv and its another versions and Gslv. The Pslv is a third generation rocket launcher designed, manufactured and operated by the Indian Space Research Organization ISRO. It is an expendable launch vehicle which can place 1600 kg remote sensing satellites into sun-synchronized orbit and 1050 kg small-sized spacecraft into geostationary transfer orbit. Pslv launched a total of 62, 27 Indian and 35 foreign satellites, including ResourceSat-2, YouthSat, XSat, Cartosat 2B, ALSat-2A, StudSat, OceanSat, 6 nano satellites, TriSat-2, AnuSat, Cartosat, IMS-1, DLR, TubeSat, Space Capsule Recovery Experiment, Kalpana-1 and several other satellites. It was also used as a launch vehicle for the Chandrayaan-1 lunar probe mission by India. ISRO built 5 variants of the Pslv based on the payload capacities of the varying from 600 kg in LEO to 1900 kg in a sun-synchronous orbit. Pslv completed 23 launches as of February 2013 and more launches planned in October 2013. The Pslv is a standard model which can launch 1678 kg of payload to 622 km into SSO. It includes 3 sub-variants Pslv 1, Pslv 2 and Pslv 3. Pslv CA is an advanced version of the Pslv. It carries 400 kg less propellant than the standard model and can launch 1100 kg of payload to SSO. The maiden flight of the Pslv CA took place on 23rd April 2007. Pslv HP is a high-performance version currently under development. It will feature upgraded strap-on boosters and payload capacity up to 2000 kg. It is scheduled to launch 7 navigation satellites between 2013 and 2015. Pslv HP is a high-performance version currently under development. It will feature upgraded strap-up boosters and payload capacity up to 2000 kg. It is scheduled to launch 7 navigation satellites between 2013 and 2015. The Pslv 3S is an advanced rocket currently under development. This variant will be able to launch small satellites into LEO in 3 stages. The design of Pslv launch vehicle. The Pslv was designed to be 45 meter high and 2.8 meter diameter. It is fitted with an inertial guidance system to accomplish navigation, guidance and altitude control missions. Pitch and yaw control of the vehicle during thrust phase of the solid booster is achieved by interposing aqueous solution of strontium perchlorate into the nozzle to establish secondary injection thrust vector control system which controls the roll argument. The vehicle is also incorporated with 2 cylindrical aluminum tanks attached to the solid rock boosters for storing the injected fuel. Roll control thrusters were also installed for roll control during the first stage. Pslv development. The development of Pslv began in early of 1990s at the Vikram Sarabhai Space Center, the state of Kerala. The maiden flight of the Pslv took place on 20 September 1993, but an altitude control error in the second and third stages resulted in the failure of the launch mission. The first successful launch of the Pslv into SSO with IRS-P2 satellite abroad was completed in October 1994. The launch was carried out from the Shar Launch Center in Sriharikota. Further successful launches followed by 1996, 97, 99, and 2001, 2, 3, 5, 7, 8, 9, 10, and 11. PSLV became the prominent rocket launcher for Indian satellite launches, especially LEO and Chandrayaan projects. ISRO launched the GSAT-12 atop a PSLV C-17 rocket from Satish Dhawan Space Center on 15 July 2011. The Mega Tropicus, a mission to study the tropical atmosphere, was launched on the back of PSLV C-18 in October 2011. The PSLV C-11 launched RISAT-1 spacecraft in April 2012. PSLV C-11-12 launched Spot-6 satellite and Japanese microsatellite Proteus in September 12. PSLV C-20, another variant of PSLV CA version, launched the Indo-French satellite Saral and 6 commercial payload satellites on February 2013. The launch Saral represented the 23rd PSLV mission of ISRO. PSLV contractors, the ISRO Inertial System Unit based at Thiruvananthapuram supplied the inertial systems for the PSLV. Liquid propulsion system and reaction control system were built by the Liquid Propulsion System Center. Satish Dhawan Space Center rendered solid propellant motors for the launch vehicle. Rocket propellant plant is supplying the propellants for the launch vehicle. Launch stages. PSLV can launch satellite into orbit in 4 stages. First and third stages are incorporated with 2 solid propulsion systems. The second and fourth stage is powered by liquid engines. The first stage features 6 strap-on boosters which can burn 139 of hydroxyl terminated polybutane attached propellant to generate a maximum thrust of 677 kN each. 4 ground lit boosters are ignited during liftoff, and the remaining 2 airlift boosters burned upon reaching an altitude of 2.4 kilometers. Ground lit and airlit boosters are jettisoned at 23.7 km and 42.6 km respectively. The second stage ignites after reaching 68.5 km and is propelled by a single Vikas liquid engine, delivering 800 kN of thrust. Fitted to a turbopump, the liquid propulsion burns 41.5 T of dimethyl hydrazine fuel and nitrogen tetroxide oxidizer for 162 seconds. Payload firings were separated at an altitude of 117 kilometers. The third stage emitted at 248 kilometers. It is powered by a solid rocket motor which consumes 7.6 T of HTPB propellant to produce the maximum thrust of 324 kN. The third stage is jettisoned at an altitude of 425 km. The fourth stage comprises a dual engine configuration and utilizes liquid propellant. This is the final stage which burns 2.5 T of monomethyl hydrazine fuel and nitrogen tetroxide oxidizer for 420 seconds to produce 14 kN of thrust. This stage launches the satellite into either LEO or GTO based on its mission. And PSLV C-45 is the 47th mission of the Indian Polar Satellite Launch Vehicle program. The PSLV C-45 was launched on 1st April 2019 with the payload of 29 satellites, including one for electronic intelligence, along with 28 customer satellites from other countries. The PSLV C-45 was launched from the second launch pad of the Satish Dhawan Space Center in Sriharikota, Andhra Pradesh, India. The PSLV C-45 rocket carried primary payloads like EMISAT and secondary payloads like ME-6P, Blue Walker 1, 4, Lemur 2 out of a total of 30 satellites. EMISAT is developed by DRDO. EMISAT satellite is based on the IMS-2, was inherited from satellite. The nature of the payload has not been officially confirmed. It was the first flight of PSLV-QL having 4 strap-on boosters and placed a primary payload emisat and secondary payload of multiple CubeSats, for example, 4 Lemur 2 satellites and M6P satellite in sun-synchronous orbits. The PSLV C-45 rocket had 4 stages. Each one has self-contained with its own propulsion system, thereby capable of functioning. The first third stages used composite solid propellants, while the second stage used earth-storable liquid propellant, and fourth one fitted with polar panels. PSLV C-46 successfully launched PSAT-2B satellite from the Satish Dhawan Space Center, Sriharikota. PSLV C-46 lifted off at 5:30 hours on May 22, 2019 from the first launch pad of SDSC Sriharikota. PSLV C-46 was the 72nd launch vehicle mission from SDSC. In this mission, core alone configuration of PSLV was flown. About 15 minutes and 30 seconds after liftoff, PSAT-2B was injected into orbit of 555 km at an inclination of 37 degrees to the equator. PSAT-2B with a lift-off mass 615 kg is a radar imaging Earth observation satellite. The satellite is intended to provide services to agriculture, forestry, disaster management domains. The Gslv Mk3 is configured as a 3 stages vehicle with 2 solid strap-on motors, 1 liquid core stage, the high thrust cryogenic upper stages. The S200 solid motor is among the largest solid booster in the world with 204 tons of solid propellant. The liquid L110 stage uses a twin liquid engine configuration with 115 tons of liquid propellant, while the C25 cryogenic upper stage is configured with a fully indigenous high thrust cryogenic engine, the propellant loading of 28 tons. The overall length of the vehicle is 43.5 with a gross lift-off weight of 640 tons and a 5 m diameter payload fire. Gslv Mk3 is the new heavy lift launch vehicle of ISRO for activating a 4000 kg spacecraft landing capability of 2 GTO in a cost-effective manner. LV-M3 is a 3-stage launch vehicle consisting of 2 solid propellant S200 strap-ons and core stages comprising of L110 liquid stage, C25 cryogenic stage, equipment bay EB, and the encapsulated assembly EA. EA comprises of the spacecraft payload adapter and the payload firing. With a lift-off mass of 640 tons, this 43.5 meter tall 3-stage launch vehicle gives ISRO full self-reliance in launching heavier communication satellites that weigh up to 4000 kg in GTO. The vehicle takes off with the simultaneous ignition of the 2 S200 boosters. The core stage is ignited at about 113 S through the flight, leading the firing of the S200 stages. Both S200 motors burn for about 134 seconds and the separation occur at 137 seconds. The payload firing is separated at an altitude of 115 km at about 217 seconds during L110 firing. The L110 burnout and separation and C25 ignition occur at 313 seconds. The spacecraft is injected into GTO orbit of 180 into 36,000 km at a nominal time of 974 seconds. On October 21st, 2022, 36 OneWeb satellites were launched from abroad. The geosynchronous satellite launch vehicle Mark III, dedicated to the provision of broadband internet services. Thank you.